The purpose of this project is going to be to create a text-based RPG that's multiplayer and is backed by the cloud. So interactions will take place right here in the terminal, but we'll be using Lambda, DynamoDB, Cognito, and a few other Amazon Web Services technologies as the backend for it. The short-term goal is going to be to create an AWS Cognito user pool and to log into it from the terminal. Cognito is an Amazon service that lets you create user pools. These are directories that provide sign-up and sign-in options for users, and we're going to want one of these. But we're going to create a new one, and the one we create is going to be managed by CloudFormation. CloudFormation is an AWS tool for infrastructure as code, and we'll be using a library called CDK, which is the cloud development kit we need to make a directory. I'm going to code name this project Snowfall. And I'm going to initialize this now. And it's just creating all of these files for us. The main stack is defined in lib/snowfallstack.ts, and this is a construct. Within this constructor, we're going to define a number of Amazon Web Services resources that will be defined together as part of this stack. And the first thing we're going to need to do is to create that Amazon Cognito user pool. We're actually going to create a user pool and then an identity pool that's associated with it. The overall aim here is going to be that once a user logs in from the terminal, they'll be authenticated with this user pool, and they'll be given an identity, and they'll be given temporary AWS access keys to be able to do very limited things within the account. We also have to create an app client to enable our app to log a user in with it. So all of these things are related to each other, so when you're doing infrastructure as code with CDK, it's good to group related objects together into a single construct. So we'll be doing that. We'll make a directory called constructs under this lib folder. And I'll just call this userpool.ts for now. In this file, I'm going to create a class that inherits from the construct class. It's going to need a constructor. The constructor will take the same arguments as a CDK construct that comes from the CDK library. The first thing is I think it's context, or rather the scope, which is another construct. A ID, which is a string, and then it can take properties. We have to call the super constructor. And then we'll define the resources that we need. We need a user pool, we need an identity pool, and we need an application client for our client to be able to log in with it. And those are also going to have to be attributes of this class. We need to go ahead and bring in the CDK Cognito library. So that will be the user pool. We also need a client. And an identity pool. Okay, I think those are all the actual resources we're going to need to define. So let's define them here. And we will use the CDK docs to determine what properties we need to define. Okay, we're defining a user pool, and here are the properties. I don't think we need to define, we can take the defaults for most of these. Let's give a more generous password policy than is probably the default, just so we can test it more easily with simple passwords. The password policy can include length and whether digits, lowercase, uppercase, and symbols are required. Let's be generous. Okay, I don't think we need to define anything else on this user pool object. So when we run this should create a user pool in Cognito, but we also need that client next. And the client is what will actually enable our application to log in to this user pool. Oops. Now the user pool client, we have documentation on here as well. And a required attribute is the associated user pool, which will just reference the one we're creating above. I'm going to skim these and see if there's anything else we should need. We don't need to generate a secret for our purposes. We are going to want to define some auth flows because we're going to want to use a user password flow from the terminal, but we're also going to make this interoperable with the React app, so we're also going to enable SRP. That should be all we need for the user pool client, and then the last resource we need is an identity pool. The identity pool is currently not provided by the version 2 CDK Cognito, and so we have to bring it in from an alpha library. AWS Cognito Identity Pool Alpha. Now let's find the documentation for that here. Cognito Identity Pool Alpha, Identity Pool. So for the identity pool, once a user logs in, they'll get an identity from this identity pool, and that identity will have a role, so that's important. But we're going to allow the CDK library to create the role, so we're not going to specify this. We're not going to allow unauthenticated identities. I read recently that assigning names to CDK resources is an anti-pattern, so we'll let CDK generate the names for the user pool as well as the identity pool. We are going to need to define authentication providers and reference the user pool there. Let's check the documentation here. We're going to be using user pools. And here we're going to reference both the user pool and the user pool client. And I think this is a complete construct that groups these three resources together. And so when we import this into our main stack and deploy it, they'll all be created, and we should see them in our account. I need to install this. Okay, this looks correct. I've done this before recently. This is what I have in another project. Let me try this. Now we've imported this, let's create it here. We're going to create it. The scope is this. The ID will be user pool. Now, in this case, referencing user pool is referencing that entire construct, which includes a user pool client, and an identity pool. Now, this is all referenced in this bin folder as snowfall stack. So if I run the command to cdk deploy that, we should create those three resources in our account. Oh, I need to run cdk bootstrap first. Okay, so now it's bootstrapping to my account and the region US East 1, which is where this Cloud9 instance is running in. And it's creating some related resources to help manage the stack as we make changes. Once this is done, we should be able to run the cdk deploy and see our new user pool get created here. Okay, the bootstrap process is complete, so let's again try to deploy the snowfall stack. When I cancel this, I want to make one change for now. And just call the snowfall stack -dev, because we might want to create multiple environments. And right now, I'll manage it this way. So the question it was asking me when I said no when I realized I wanted to cancel was just anytime there's a change that has to do with IAM policies and security, I'll have to specifically confirm them. And I'm okay with doing this. So this will take a few minutes, and once it's done, we should see a user pool appear here. It's already appearing, and this is a generated name for the user pool by CDK, which again I heard was a best practice from either a video or a blog post recently. This user pool should also have one client under app integration, and that's already been created. And there should also be an identity pool associated with this. I believe this, based on its name, is the one that was just created, user pool, identity pool. So I think all of our resources were created, and it's reporting that the deployment is done. When we make a React version of our client application, we'll be using the Amplify library to log in. But when we use our terminal application, which I think we'll build in Python, we're going to need to use some Lambda functions to get the login function working properly. So we're going to create two Lambda functions, one to sign up a new user, and one to log them in and return temporary access keys for the role for an authenticated user. We'll start with the sign up function. First, we need to create a place to store the code for the Lambda function. Since it's part of our infrastructure, it will be part of this infrastructure repository. When we get to actually adding the Lambda function to our CDK stack, we will specify where in this repository to pull the source code from and upload it to Lambda. So I think we will make a directory in the root of this project, perhaps called Lambda source. We'll make this one for the, actually let's make this more nested. We'll make a folder called auth, and we'll put the folder sign up under it, and in there we'll create our Lambda function. We'll call this app.py for now. I'm not sure what the best name for it is, but we'll write this Lambda function in Python. And what this Lambda function is going to need to do is it's going to take a username and password submitted by the client and then sign that user up. So the first thing we'll need to bring in is the Boto3 library, which is the Python library for interacting with Amazon resources, and it will be automatically installed in the Lambda context for us. And we're going to need an identity pool client. And as far as the permissions and the credentials for this context, that will also be provided by the role given to the Lambda function, which we'll make sure has the permissions to do what we're asking it to do. Okay, so now we're going to need to define our handler function, which will take, I believe, an event and a context as its arguments. And the event will have the username and password. We may have to adjust this a little bit once we go to figuring out exactly how this request will be submitted by the clients, but we'll just change these lines when we get to that point. And then all we should need to do is call the signup method on this client. And the things we need to pass to this, let's double check. Boto3. I had looked this up recently, but all of this is very well documented. So we'll need the client ID. Now, the client ID will be provided by the Lambda environment, and we'll have to specify that when we create this in CDK. For now, we're going to import OS and read that value out of the environment. The client ID, I think it's getIn. So we'll read that out of the environment and then pass it to this function. And the only other things we need, I think, are the username and password. Let's check. Yep. We don't need a secret hash because of how we set up the user pool. Oops. Now let's see what the response will look like. We're going to want to log, probably by printing the output. So I don't know what happens. I hope this throws an error if it fails. Okay, good. There's exceptions. So we can probably wrap this around in a try catch or try except. We'll probably want to clean that up, but for now I just want to get a working example. So provided there's not an exception, the response we get should have true or false about whether the user was confirmed. We'll talk about that more in a second. And then the user sub, which is actually going to be very important for scoping permissions. And we'll probably want to log this. So the user sub will be in this response. And these logs, this output should be available to us in CloudWatch if we set this up properly. The next step will be to make the Lambda itself. So let's define a new construct. This is going to be a Lambda function that has what's called a public function URL. Because when the user's signing up, there won't be a logged in user yet. So we'll make this a public facing function. And this is a fairly new feature of Lambdas. I haven't used it before. Usually I've put Lambda functions behind an API gateway. But in this case, we're going to create the sign up and login functions as Lambdas with their own invocation URLs that are public. And then other functions that we want the client to call will be a little bit different. The role that a logged in user will get will have the authority to call those other functions. But since they won't be logged in yet, we have to make the sign up and login ones public. So we're going to create a new construct that we will call a public Lambda for now. And it's going to be similar to the user pool in that we need to extend this construct class and take a scope ID and any properties we need. So let's first import this and export the class public Lambda, which extends construct. I'm not sure what properties we'll need yet. Let's start with the constructor. The scope is another construct. The ID is a string. And we'll take some props. And as always, we need to call the super constructor. Now let's look at the CDK documentation and see what we need to do. We're going to be creating a function object. So let's go ahead and import, similar to how we imported Cognito. And we will want this to be a property. Okay. The context is this, and we'll use fn as the ID. So what do we need to provide it? We need a source for code, and we need the handler. Now the handler is going to be app, because it's app.py.handler, because handler is the name of the function defined in it. We could use different names, and then we just have to specify it as handler. We'll come back to code. Let's see what other properties we'll care to define. The runtime. The runtime will be Python 3_9. And how is this defined? This is under lambda.runtime. So I think lambda dot runtime dot, yes. That will be the runtime, Python 3.9. I don't think we need, oh, we do need to specify the environment. Because it's going to need to have client ID. And we'll need to take that as a prop. User pool client ID. So we will have to pass that in when we call this method. Actually, this is a abstract class for, not abstract literally, but it's an abstraction of a public Lambda function, so we shouldn't do this. We should pass the entire environment in the props, because we'll use the same construct for other Lambda functions that are supposed to be public, and we'll want to be able to pass any kind of environment. I don't think we need to specify any of these other things. We might want to go back at the logs because we don't want to make sure we can find the output of the print statements in this function. We're not doing VPCs right now. So let's go back to code. To specify the code is from an asset that's locally on our disk. So lambda.code from asset. Now we're also going to want to receive this as a prop. So path to code. So when we call this construct, we're going to need to pass in the properties, the path to the code. We don't need to, we'll join it on the outside, and the environment. And those are the only two things we should need, because I guess we'll assume for now that we're going to write all of our functions within this project in Python. If we want to change that, we can make this just default to Python 3.9 and then check if the prop specifies a different runtime. But for now, I think we'll just write all of our Lambda code in Python, and the only props we need are the path to the code and the environment, but we can easily change that. There's definitely more work to do in terms of defining that public URL to invoke the function, but I want to try to call this in our stack and deploy it and iterate from there. So I'm going to import that public Lambda. Let's be alphabetical here. And this will be called the sign-up Lambda. As usual, the scope is this. We'll give it an ID of sign-up Lambda, and for props, we need to give it the path to the code, which will be path.join. So in the context of this file, dir name is lib. So we need to go up one and into Lambda source. And then into auth. And then into signup. I believe I'm giving it a path to a directory here. Yeah, because if we put multiple things in this directory, we want the whole directory. So I think that is right. The import path. The path to code, and what was the other thing that we need to bring in? The environment. We need to give the client ID, because that's what the function needs, and that will be from user pool. Remember, our user pool construct has a user pool client. And I'm going to need to check the documentation again to see what property. It's probably .clientID, but I want to check. Cognito user pool client has these properties, user pool client ID. So userpool.userpool.userpool.client ID. Let's try deploying this and see what happens. Okay, so it's creating a role for the function. So we might need to assign some permissions to that role as well. Those will probably be things we end up passing into this props object as well. Now it's creating the function, so we should see that soon. Okay. If I look at code, we see the code that we created locally up here in the Lambda function. Now, before we go further, we could test this by passing in a custom event. Test. And we only need to take two inputs, username and password. Okay, now this is saved. When I hit the test button, this should execute, including any print statements, and we can test. Okay, there's a timeout, so we need to right away increase the time to be above 3 seconds. That can be done here, I believe. Timeout is a duration. This is on the CDK core. The maximum, if I recall correctly, is 15 minutes. Let's set this to 5 and see what happens. Let me double check that the default actually is 3 minutes. Oh, sorry, seconds. The default is 3 seconds. We don't need to go to 5 minutes. We can go to 1 minute for now and see how that performs. Oh, this is the wrong place to put this. This goes here. The deployment is complete, so when I refresh this page, there will be the new timeout is 1 minute 0 seconds. Now we can run the same test as we did before, and it won't time out after 3 seconds. Okay, I think I misnamed this to be Cognito IDP instead. Now, if I make changes here, they'll be clobbered when I deploy again. So I just want to change it here real quick and test it, but then I've got to make sure I capture that change once it works here. Okay, now I'm getting an error that signup is not allowed for the user pool. So that is progress. And that's probably a change I need to make to the user pool settings itself. Self-signup enabled. So I'll go to our construct, which is for a user pool that groups together all the related constructs. And this is an option on user pool, and it was called self-signup enabled. We want to set this to true and update. Okay, the update is complete, and let's refresh the page and make sure that it says Cognito IDP and run the test again. We should get a different error, if anything. The response is null. Oh, we didn't return anything, so I bet that works. Let's go to the user pool itself and check. We can already see there's one user, and that was just created. Now separately, a user has to be confirmed. This is what you experience when you sign into a place and then have to click a link in your email. So we don't have all that infrastructure set up for this test application right now. I'm going to manually confirm this user. Now it should be able, someone user 001 should be able to log into this user pool, and we'll test that with the next Lambda function. We'll go ahead and add the Lambda function now, and then with a separate step, we'll make a Python client that first signs up a user, and then a user can log in. So we'll create a new folder for the Lambda function. This one will be called login. Also app.py. More environment variables are going to be required for this step. Handler takes event in context. We're going to import OS and Boto3. And we're going to need an IDP client, just like last time. And when logging in, we will once again have username, which we can get from the event, and a password, which we'll also get from the event. Next, we can initiate auth using this Cognito IDP client. This is possible because of the authentication options we provided on the user pool. We need to give it the client ID from the environment. So we'll copy that over from here. We have to specify the auth flow we're using, which in this case is something called user password auth. One of the auth types we explicitly are allowing. And we have to give it auth parameters, which for a user password is a username and a password. I believe this is all we need. Let's check the initiate auth documentation. User password auth takes username and password. This, I believe, is everything we need for this part. And now the goal of this function is not only to log the user in, but then to go to that identity pool and get credentials, temporary credentials, for an IAM role that all logged in users will have, so that that can be returned to the client. That will enable the client to make direct API calls. So let's capture this response as the auth response. And the auth response will contain an authentication result, and what we're looking for is something called an ID token. And that is inside authentication result in the response. This is called an ID token. Then this ID token can be exchanged for credentials with another service for the identity. Which should also be documented here. Cognito identity. So there's identity and identity provider are separate services. So this is what should allow us. This is get ID. We'll have to make 2 calls to do this. The first call is to get ID, which will get an ID for the identity from the token. And then we can do get credentials for identity once we have that identity ID. So first thing is to get the ID. So using this identity client, we will call get ID. That takes an account ID, identity pool ID, and logins. I don't think we need account ID. We do need identity pool ID. We'll also need to get that from the environment. We also need the region and user pool ID. We need to construct a special string for this login parameter. Is the reason we need these things. And so this login event to that service corresponds to the ID token that we just got. And this is specified here. There's different login types, and so Cognito IDP region AmazonAWS.com/user pool ID. Giving an example here. So this format string will create a string like this. This one right here. The response. That response will have an identity ID. Then we take that identity ID and exchange it for the credentials we need, and that's what we need to return to the client in the later step. Get credentials for identity takes identity ID and logins. And logins is going to be that same thing. Now the response will have that identity ID and credentials, and inside the credentials will have access ID, secret key, session token, and expiration, all of which can be returned to the client because they will correspond to a role that is designed for the client to have. When we go and clean this up, we'll have to wrap this around a try-catch block. Maybe I should do that anyway, right now. Not try-catch, sorry. Try-accept. Exception as E. We also, in the case of, I should edit this sign up one. So for sign up, we return an error if there's an error, but we should also return an object saying that the sign up operation was successful. And here we want to return if all of these things happen, there was a success. And then we'll return credentials. which will be what we get from this credentials response operation. Yes, this will have a dictionary, get credentials for identity, we'll have credentials, and then it'll have these strings in it. Cognito identity client, what's wrong with O? Okay, we've already defined the construct for a public lambda, so we just need to do the same thing we did to make the signup lambda here. So in our snowfall stack, I can just copy these lines and edit it for our purposes. Instead of being signup lambda, this will be the login lambda. That also has to be its ID. The environment is going to need a few more things in it, but the path to the code will be that login directory instead of signup. Now, what else do we need? We need the identity pool ID. That is also provided to us by this user pool construct, userpool.identitypool.identitypool.id. We need the region. I'm not sure if we have anything that can reference that. Maybe okay, all constructs have a reference to this env thing that has their region. I believe all constructs have that by default. And we need the user pool ID. The user pool, the user pool client, and the identity pool are all grouped together. And this is also going to share that 1 minute timeout. If we want to have functions have different timeouts, we'll have to make the props object take that, and then we can pass them in individually. For now, everything that's not defined in props is defined here and will be common to all of our public lambdas, which I'm only planning on having these two. And we can verify that our environment injection is working, I believe under configuration. Yes, so it shows right here the environment variables we have. So all of those variables from the, or all those values from the user pool construct got successfully injected. Client ID, identity pool ID, region user pool ID are the same ones expected. Client ID, identity pool ID, region user pool ID. Now, since this is a different function, with to configure a new test event. Login test user 1. Same inputs. Now the password is going to have to match what we did last time. Unable to marshal response object of date time is not JSON serializable. While I'm at it, I want to test what happens if I try to use the signup lambda function with a user that's already been signed up. So last time this ran, this actually created user 1. If I test this, I should get an error. The user already exists. Oh, and it's showing this in this format that we created. The success key is false. The message is this. Now I need to go back to the other one and see why that, investigate more closely why the login lambda failed. Unable to marshal response. Object of date time is not serializable. Credentials, resp, credentials. What did this have? Expiration is at date time. So I bet it actually got credentials successfully, but this date time key within the credentials can't be serialized. If that's the case, let's just go ahead and make the update to this code now. and break it apart. We only need the access key ID, secret key, and I don't think we need anything else. Actually, I think the SDKs will only need access key ID and secret key, so that's all we need to return for now. Credentials response has the credentials object, and that has access key ID. Access key ID and secret key. Are those the only two we need? Maybe we can give a session token as well. We might need that for the SDKs. Okay, let's redeploy this. I should leave this page. That succeeded, so taking a look at the login function now, let's just verify that our changes were added and run this test again. Now we see that this completed and we have access keys and secret keys. This means we'll be able to use a client to interact with these lambdas once we make them have public URLs. Sign up a new user, and then provided that user gets confirmed, a process we'll clean up later. Go back to this login function with the same credentials, and then grab an access key ID and secret key that can be used. So now that these two things are in place, we'll go ahead and I think the next step will be to add the public URLs to invoke these functions, and then write just a basic script that interacts with them. To create a function URL, all we need is a function and an auth type. CORS is currently not relevant. CORS is something if the client was going to be in a browser. I like the idea of making a little app where some kind of command line Python client and a React application are interoperable. But the login process on the React app will use something called Amplify, so we don't need to think about CORS. We're going to be using this none option to bypass authentication and create a public endpoint. The definition for this belongs with the public Lambda construct we've created. Just like with the user pool, we created a couple different resources and bound them together. The function URL is tightly coupled to the function itself as far as its purpose. So let's make this also a property of the construct. And create a new one. Now when we run this as it is, this is going to be adding two function URLs, one for each, because this construct is called for both the login and the sign up app or function. So this is a function URL, and we only need two properties. One is the function, which should refer to this. And the other is the auth type. Function URL auth type .none for this one, for the public Lambda. We'll create other constructs that will group together related resources for Lambdas that are not designed to be public, so there'll be different things here than what's going on right now. So if we deploy this, I should be able to find, once it's deployed, I should be able to find those URLs in our console. Now that this is complete, I should be able to go here and find evidence that there's this function URL. It says none right now. I'm hoping if I refresh, there's one. And there is one. So we can make a call to this function, or to this endpoint, and hopefully I'm thinking you can just post a request body that looks just like this, and everything will work the same. So the next thing to do is to start working on, actually the next thing to do is to make sure that this stack outputs these endpoints. This is called something called a CFN output. CFN output sign up Lambda URL. This, if we use CFN output, this means that the stack will have certain outputs for us to see. So when we run it in the command line, it will actually display them. And then if this stack was going to be imported by something else, that could also be used. Oops. Sign up Lambda URL. The value of this should be sign up Lambda dot function URL dot URL. And we want the exact same thing for the login Lambda. Now if we run this, once it runs, there shouldn't be any other changes except for producing this output. It should print out these things every time we run CDK, and then we'll bring that over into the environment of another program that will act as the client. Okay, here it is. We will need these two things for the next piece. We'll make a new directory called Snowfall Python Client. Okay, we'll start building here. Python has a request library, which I think should be part of the standard library. Nope. So we'll specify our Python dependencies in requirements.txt. That's why. Okay, let's create a basic sign-up app. Please, well, let's do a sign-in first. Please log in. Then we'll grab the username and the password. We don't need to print yet. I'm confident how this works. The next thing we need to do is then call the Lambda function. So let's get our env file set up. And before we forget a gitignore file so we don't accidentally commit the env file, I should probably go ahead and do this. Ignore PyCache directories. Okay, env. We'll want two environment variables for now. Sign up Lambda URL and login Lambda URL. The login Lambda URL is this, and the sign up Lambda URL Okay, this python.env library will bring in the contents of the .env file and put it into the environment for us. So all we need to do is this. And then we also need to make sure we install that. Okay, .env is installed. Okay, nothing's happening yet. Okay, now to log in, we just need to send a post request. Hopefully that's what we need to do. I actually haven't researched how to use function URLs. I'm assuming we can send a post request. I have to import the OS library in order to actually read the environment variables. Now, after .env is loaded, that's when I have to actually get them all. So the login lambda URL should be called login lambda URL in the environment. So let me verify that. Yes. So we'll send a post request to there. I think this is how it works. Then for now, let's just print the response. Actually, if the response works, it should give us a JSON object as well. That should be whatever is returned from the app.py file. I'm kind of guessing a little bit how this works here. So let's try to sign in as user 1. Okay, so it didn't work, but why not? It looks like when trying to decode the response, there was a problem. Let's just print the response and see. "502. That's internal server error, which is different. I wonder if this is how it's working. If I give it okay, this CloudFormation example is more or less what we're doing, including auth type none, create lambda function. Okay. All right, so tell me how to actually, invoking function URLs. Function URL is a dedicated HTTPS endpoint. It has the following format. They're dual stacked. You can invoke your function. You must have lambda.invoke function URL permissions. But we said none, so it should be able to do that anyway. If your function URL uses the AWS IAM auth type, you must sign each request. If you don't use a tool, if your function URL uses the none auth type, you don't have to sign your request. You can invoke functions using a web browser or any HTTP client. To test a simple GET request to your function, and it takes a string parameter message, it would look like this. Okay, so I should be able to send a post request. I should be doing this correctly. When a client calls your function URL, Lambda maps the request to an event object before passing it to your function. Your function's response is then mapped to an HTTP response that Lambda sends back to the client through the function URL. The request and response event formats follow the same schema as the Amazon API Gateway format version 2.0. I think I'm not doing this right then. User 1, password 1. Recent invocations. So it looks like the key username is not being found when we submit these things. So let's print the event. I thought we might have to be changing this. So let's print the event and see what it looks like, because there's a mapping taking place, and it's probably the actual data we pass is probably some subkey of event, and then we just have to change these two lines. But let's redeploy. That's deployed, so I want to call this again. Wait a second, and then look for CloudWatch again. Internal server error again. Okay, this is the event object. It's got the headers, body. Headers, request context. Okay. Oh, and the body is a string. So I've got to cast this string to JSON. Let's bring in the JSON library. So whatever's in the body has to get cast, and then this should work. This will also have to happen here. So let's go ahead and update them both right now. Okay, now that that's successful, I kind of want to go back and verify that it looks different now. Okay, good. So now I'm seeing this attempt to load the event body and get the username and password from it. So now I'm hoping this is more successful. Okay, perfectly. So we're getting these credentials back. That's the goal. What we actually will do when we build on this is ask for a login, of course, not display the password as it's being typed. And then with this object, we can instantiate SDKs and start interacting with other Amazon resources as we build them, including DynamoDB and other Lambda functions, and S3. So I think the next thing to do, well, is some error handling thing. I'm hoping if we... So this stuff took place outside of the try-catch block. Any other errors that take place should cause this exception. Now, we probably don't want all exception strings thrown back to the user, but for now, I want to just test what happens if I try to log in with improper credentials. That was proper credentials. Let me. Okay, good. Incorrect username and password. So theoretically, I should get that if I try to log in as a non-existing user. It doesn't exist. Okay, so we probably, at a certain point, don't even want to distinguish between these two errors. From what I understand, this is a bad practice to even reveal whether or not that username exists. So this is a stopping point for this video. I'll put any Git repositories in a description. And the plan for next time will be to clean this up a little bit, well, to rather clean this up a little bit, and probably have a loop. We ask a user to either register or log in. Make sure that they can do both of those things. And then, once they've logged in, we're going to want to go back to building our text-based RPG. And the next step will be to have a user create a character with a name, start at level 1, 0 experience points, probably no other attributes right now. That will all involve DynamoDB. And so hopefully all of that will happen in the next video.